All right, so let's go over the first page of the worksheet, which is the side that said 10.4 on it. I know we did number 1 together. Your graph for number 2, your tree diagram for number 2 should look like this, where you've got waffle cone, and then off of waffle cone, you've got your chocolate, vanilla, and strawberry options. And then off of the sugar cone, you've got your chocolate, vanilla, and strawberry options. How many is that in total? 6. Yeah, you have two cone options and 3 flavor options. 2 times 3 is 6. Number 1 was 12, where we had 3 pets and 4 names. Okay, we didn't have to do the tree diagrams for 3 and 4. You could just literally write out the outcomes, but you did have to show your work, show what numbers you're multiplying. We have 3 sizes and 3 crusts. That's 9 outcomes, 2 transmissions, 2 doors, and 4 colors. That's going to be 16 outcomes for number 4. Number 5 was not 2 times 10 to get 20. It was 2 times itself 10 times, because there was 10 questions, and 2 to the 10th power, or 2 times 2 times 2 times 2, 10 of them, is 1024. Number 6, when you do the male female choice, face shapes, eyes, noses, mouths, hairstyles, you should have gotten 18,137,088. Questions on the front page. Okay, flip it over to the back page. Number 1 we said was independent because when you spin the spinner twice, you still have all the same options you had the first time you spun it. So the events don't affect each other. Yeah, it's the same spinner, but as we mentioned, a number's not falling off of it. The number you roll can still be rolled again, second time you do it. Number 2, this was dependent. Once a person was chosen for president, they could no longer be chosen for vice president. So you're removing one person from the list of candidates, and so that makes this a dependent event. Number 3 and 4 were both independent events because the coin flip and the spinner have no effect on each other. Yeah, Brennan?
I'm confused. That means have a more likely chance of spinning a 5.
For which one? When it says not spinning a 5, there's a 4/5 chance that you get some other number. That's what that means. Okay. Back to number 3, spinning an odd number. There's 3 odd numbers up there, 1, 3, and 5 out of 5. So you have 3/5 chance of doing that. You have a 1/2 chance of flipping heads. That's going to give you 3/10. There's nothing to cancel there, so we're ready just to multiply. Number 4, not spinning a 5. That means every number but 5. There's 4 other numbers up there. So you have a 1/5 chance of spinning a 5, but that means you have a 4/5 chance of not doing it. And so then flipping tails is a 1/2. You can cancel the 4 and the 2. If you don't cancel, you end up with 4/10. Please do not leave it as 4/10. I won't count it for full credit. Reduce it to 2/5. Numbers 5, 6, and 7 were all done without replacing. So for number 5, you draw out the 6 and then go for the prime number. There's 1 6 up there, so you have a 1/7 chance of doing that. And then the prime numbers are the 2, the 3, the 5, and the 7. There's 4 out of the 4 of those. But since you didn't replace the first number you chose, the 6 is no longer there. Now it's 4 out of 6. Dependent events will always lower your denominator by 1. Reduce the 4 6 to 2/3, and that's going to multiply to give you 2/21. Don't leave it as 4/42. Number 6, choosing 2 odd numbers. Well, there's 4 odd numbers up there, 1, 3, 5, and 7 out of 7. Once you pick one of them, you're going for another one. Well, now there's 3 odd numbers out of 6. So you can cancel quite a bit. You should end up with 2/7. Don't leave it as 12/42. That cancels all the way down to 2/7. Number 7, you randomly pull 2 bills from your wallet. What's the probability that they're both $20 bills? There's 2 out of 6 bills in your wallet that are 20. So you have a 2/6 chance of drawing the first one, and then a 1/5 chance of doing it again because you're keeping that first $20 bill that you kept out of your wallet. And so you only have 1 out of 5 now. What's the probability of me drawing another $20 bill, a third one? Aiden? 0. Yeah, I don't have 3. All right, my next fraction will be 0 out of 4, which if you multiply something by 0, doesn't matter how many other numbers you had. You can't pull 3 $20 bills out, assuming you keep them. If you put them back in, it resets each time. We could do that, but we're keeping them. Number 8, we said was 1 out of 36. And number 9, you have 3 out of 6 chance of rolling even, and also a 1/2 chance of rolling odd. They're both 1/2. 1/2 times a 1/2 is 1/4. Questions on this worksheet? All right. So today's lesson then is a step away from probability. Go ahead and download 10.6 off of Google Classroom. 10.6 is called Samples and Populations. We started this chapter, if you remember, doing a mean, median, and mode worksheet. Do you remember those? And we had outliers. Which of those measures are you supposed to use if there is an outlier? Do you remember? Is it mean or median? Median. Use the median if there's an outlier. And here's how I remember that. So if there isn't an outlier, we always use the mean. We like to use the mean. Okay, the median is the one you want to use if there's an outlier. And here's how you can remember that. If you're supposed to find the mean, or the median, sorry, if you're supposed to find the median, you have to line all the numbers up from least to greatest. Well, an outlier, by definition, is a number that's much, much bigger or much, much smaller than the rest. So when you line them up from least to greatest, your outlier is going to be either on the left or on the right. And when you start scratching towards the middle, the outlier is the first one that gets scratched off. Okay, so it has the smallest effect on the median, has more of an effect on the mean. So we use the median if there's an outlier. We're not finding mean, median, and mode today. Okay. We're actually going to talk about what you do before you find mean, median, and mode. Mean and median are things that they're ways of interpreting the data. We're not going to talk about interpreting the data as much as we are going to be talking about collecting the data. So when you're talking about a population and a sample, you're talking about ways to collect the data. A population is an entire group of people or objects, and a sample is part of the population. A sample is part of the population. Brandon, please don't spin the quarter. Thank you. You can use a sample to make an inference or a conclusion about the population. If I was going to take a poll of Western middle school students, okay, to see how many of them do a sport after school, okay, at any point in time during the year, I can't ask all 650 students, even if they were all here, let alone in a COVID year. I still don't have time to do that. So what I might do is take a smaller sample. Okay. Now, tell me which of these two ways would be the best way of sampling the students? Option one, going into Mrs. Lazar's room during sixth period and saying, how many of you do a sport after school, writing those results down, and then using those results to make my inference, okay, my conclusion on that. Okay, there's option one, or option two, call 3 students out of every homeroom and getting that information and recording it down. It's about the same number of students, probably. I don't know how many she has during her sixth period. Maybe I should have said first period. I don't know, whatever her largest class size is. So let's say in all, it's about 30 kids, we'll say. Which of those is the best way of getting a good sample? What do you think, Aiden? Option two? Is that what you meant? Yeah. So pulling 3 kids out from every homeroom? Okay. Does everybody have a homeroom? Everyone has an SLT, right? So everyone had a chance of being called. Yes, I didn't call everybody. I can't just don't have time for it. Okay. So I think you're right on. Okay, that'd probably be the best way to do it. If I go to Mrs. Lazar's first period class, does everybody take first period class with Mrs. Lazar?
No.
Not everybody does. Not even all the 6th graders. Some of you did, but I wouldn't be asking you because now you're a 7th grader. See how that's not really a good representation of the entire school though? Because if I just wanted to know 6th graders, that still wouldn't be really good because I'm just asking the ones Mrs. Lazar has. But if I was just asking Mrs., the Explorer hallway, sure, that's fine. But I'm trying to get, Western middle school data. So I got to include everybody. I got to make sure everyone had a chance of being included. And that's what we're going to be talking about today. Okay. Populations and samples and what makes it a good sample and what's a really bad sample. Okay. So if I'm collecting data, here's the kind of the flow chart that I would follow. First of all, identify where my population is. Okay, Western middle school. That's it. That's what I want to know. I want to know how many Western middle school students play sport after school. Then I'm going to select my sample. Then Then I can interpret the data. This is the step where mean and median comes in. Okay, we already did that part. We're talking about the precursor, what you do before you find the mean and median, the mode, and start analyzing the data. And once you analyze, please put the coins up. Once you analyze the data, then you can make a decision. That's what an inference is. Okay, an inference is a conclusion about it. So now I can say, okay, with these results, I believe that so-and-so students, these many students are the ones that I predict that would do an after-school sport. So let's practice identifying populations and samples. We'll start back here with Brennan. Brennan, we have the students in a school and the students in a math class. Which of those is the population and which is the sample? There you go. Okay, so we got the population. We can just abbreviate P and S. Okay, population is the students in the school. The sample is just one class of them. Aiden, what about a grizzly bear? The grizzly bears in the park with GPS collars or the grizzly bears in the park? Which one's the population? Which one's the sample?
I think the grizzly bears in the park would be the population.
Okay, that would be correct. That's all of them. And then if you just count the ones that have GPS collars on them, that's a smaller number. Samples are always smaller than the total population. Okay. Elijah, what about 150 quarters or all quarters in circulation? I agree. Yeah, and then our sample of 150 is obviously a lot smaller than all the quarters in circulation. And then D, Catherine, all books in a library or the 10 fiction books in a library? Good. Yeah, and then my sample are these 10 fiction books. Okay, so as much as I'd love to say you're going to see a question like this on the iLearn, the questions you're going to see on the iLearn aren't going to be what's a sample and what's a population. They're going to ask you which of these 4 choices is the best way to conduct a good sample. And so that's what I want to talk about now. When a sample is collected at random, each member of the population is equally likely to be selected. So we like samples that are done randomly, okay? If a sample's not done randomly, that means it's done biasedly, okay? We don't like biased samples. You guys know what the word biased means? What's it? Okay, so an umpire being biased for a team. Let's say the umpire has a kid on that team, right? So even if he doesn't want to be, you kind of almost are partial. Would you think it's fair if so-and-so's dad's the umpire tonight and he's on the other team? If you're in a talent contest and I was judging it and my kid was out there doing the talent show. Now he's not at 9 months going to be out there in the talent show. Maybe cutest baby contest for sure. Takes after me for that. But no, that. Yeah, it wouldn't be really fair. To be biased means you favor one thing over something else, okay? And you're probably not the best person to make a fair judgment, even if you tried. We don't like biased samples. If I go and ask just Mrs. Lazar's students, that would be biased to Mrs. Lazar's students. That doesn't represent the entire WMS population. So we have 4 different samples. I want you to tell me whether you think they're random ones or not. And if they're not, we would know they're biased, but we'll talk about that word later. You want to know the favorite extracurricular activity of students. Extracurriculars, those are anything you do outside of school, clubs and sports. Okay. Determine whether each method will result in a random sample. Now, keep in mind, we're trying to figure out what the favorite extracurricular activity is of students at Western Middle School, which means we need to make sure that all Western Middle School students had a chance of being included in the survey, whether they were actually asked or not, at least they had a chance to. Okay, so A, you ask the band members. What do you think, Owen? Is that a good representation of the school? No, it's not. It's not random. What do you think the band members are going to say? Yeah, they like doing band or marching band, whatever, you know, that kind of stuff. Probably why they're in it. If they weren't in it, they wouldn't take it, I would hope. All right, so that's not random. What if I published a survey in the Paul print? Does everyone have a chance of reading that survey? Sure. Even if you don't pay a quarter for the paper copy, you could get it off the school's website, right? Now, you could argue, well, not everybody reads the Panther Paul or Paul print, whatever it is, the Paul print. Okay, you could make that argument, but everyone could read it. So I'd say this is random. You didn't exclude anyone. I didn't make it, I'm not charging $5 for a copy and then just saying, I'm going to ask just the kids that bring $5 in what their opinion is. All right, everyone has a chance of reading it. What about asking every 8th student who enters the building? Would that be random?
Yeah.
Do I have control over who's entering the building? So I'm not gonna favor anyone, right? Okay, so that would be random. And you could say, well, you've already determined you're going to ask the 8th person. Sure, I am going to do that, but I have no control over who that 8th person is going to be. And what I don't want to do is go ask my friends. Okay, that's not the way to conduct a good survey. I'm not saying you can't ask some of them, but if you just ask your friends, which are probably have similar interests to you, and you might have friends that are doing the same sport as you are, they're going to say probably the same thing. And so you want to make sure you want to include people who don't even play sports. They should be included because they're included in the WMS population. So asking every 8th person is a really good way. Now, where would I need to stand if I was going to do that? But if I do one of the 3 doors, 2/3 of the kids, I'm not going to ask.
So all 3 of them.
How can I stand at all 3 at one time? Is there another location I could be?
Camera.
Do at the end of the day, like, or at the beginning of the day, you know how the people have the card? They're just.
Oh, the little side.
Where you walk in.
Okay. That car, the last time, you mean the like one where they're out in front of the library? Yeah, that'd be a good spot to do it. Because whether you're a bus drop off or a parent drop off, or 8th, 6th, or 7th grade, doesn't matter. Everybody walks past the library. 8th grade, yeah, they do. Yeah, they do. They-
No, they walk through, they walk through the doors right over here. They don't walk through the doors that make.
Oh, you're right. Well, I think that's just for this year because they didn't, because of COVID, they were trying to keep everyone from crowding through one door.
Yeah, I did it.
Did they?
Someone does.
Okay. Theoretically, you'd get most of our students, if you stood in front of the library, because 8th grade going one direction, 7th and 6th going a different direction, the 6th splits off, obviously. And that'd be a good place to stand, and you could just count every 8th person. You'd probably want some help though, because everyone kind of comes at once, and you'd probably want some other people to say, hey, you take this 8th person, and I'll count the next 8th person. I'll take them, and you take the next one. Dane?
Or you just have 2 other people, one at one door. Yeah.
Okay, just cover the doors. If you have enough people, you could just cover all the entrances.
But we're saying, where the paths split on the sidewalk.
But then what about student drop off? See, that'd probably be in the building. All right, I'm not doing the survey, so I don't worry about it.
Camera.
What about them?
So you can look through the camera, look to someone, and then there's just finger on.
I'd rather just be there so I could ask them versus watching it 2 hours later.
You could use the intercom, it's like, hey, in the 6th grade hallway, walking through the door, yeah, you know, the blue shirt.
All right, all right. What about if you ask the students in your SLT? Is that random? No, that's not random. That's just as bad as asking Mrs. Lazar's first period class. You're favoring one class over others, and if it's your SLT, then it's just a small portion, just 7th grade students. Not everybody had a chance of being asked. Okay. All right, to make valid inferences about a population, you must choose a random sample. We like those. If it's a random sample, it's good. So that it accurately represents the population. So what we're going to do now is we're going to look at 3 different ways that a survey was conducted. I'm not really interested about the results of the survey because I can look at the results of the survey and they could be completely false. The only way that I know that they're good results is if the survey was conducted randomly. Okay, so don't look at the numbers and try to say, well, I like these numbers. If the survey wasn't random, then it can't work. So a new power plant is being built outside of town. In each situation below, residents of the town are asked how they feel about the new power plant. Determine whether each conclusion is valid. And we're going to do that by thinking about how they did their sample. A, A local radio show takes calls from 500 residents. The table shows the results. They conclude that most of the people in the town oppose the new power plant. How do you feel about that?
I don't know.
I think it's biased. I think you're right. And I'm not going to blame the radio station, even though not everybody listens to that radio station, right? So you could argue right there, well, this isn't random. It's just people that listen to that radio station, okay? But here's a second reason why I don't like it. Probably don't like it more for this reason than the other. They're just taking people that called in. They didn't even conduct a survey. They just made the people reach out to them. Now, I don't know about you, but I've listened to a lot of sports talk radio, and when people call in, they call in because they're upset. There aren't too many people that call in and say, you know, I really like where we're going. Just wanted to mention that. Thanks, bye. They call in and they're like, I don't like that coach decision. And then someone, yeah, I didn't like it either. And so you're more likely to be upset about something if you're going to call in than if you really like it. So yeah, they got a lot more calls. Now, I'm not saying that the town doesn't like or does like the power plant. I'm just saying that the way they did the results, I think these numbers are probably a little bit more off than what they're right. Okay, so I'm going to say this is not valid. It wasn't done randomly. They just took callers that called in. If they would have posted something on their website, at least people, yeah, people who didn't want to call, especially, you know, if you're in the minority, you're like, I actually like it. Well, if everyone's calling in and bashing it, you're probably like, well, I won't call in today. Well, you feel a lot better if you just go log onto the website and say, you know what, this is how I feel. Yeah. So if they didn't do that, they just took people that called their radio stations. Again, it's not valid. B, a news reporter randomly, okay, I like that, surveys 2 residents outside a supermarket. The graph shows their results. They conclude that half the town's for the power plant and half the town's against it. Do you like this survey?
No.
It's done randomly. What don't you like about it?
There's only 2 people representing the whole.
There's only 2 people. Yeah, so because one person said they were for it, one person said they were against it, they're just packing it up and going home and saying, you know what, we're split. The town's split. I like that it was done randomly. Don't get me wrong, but you can't do just 2 people. That's not enough to represent your population. At least do 100, maybe more, 200. Okay, so this is not valid. It's not large enough. Okay. And then C, you randomly surveyed 250 residents at a shopping mall. The table shows the results. Again, I'm not concerned about the results as I am about how the survey was conducted. Would you agree with that this is a good survey, or would you say that they did something wrong? It is a good survey. These are valid results. Okay, I don't know how big this town is, but let's just say it's the size of Kokomo, for example. We only have 1 mall. Not everybody goes there, but a lot of people do. I'm not really leaving a ton of people out if I say, hey, I'm going to go to the mall and ask every 8th person that walks in. Okay. What's another place you could go and do a survey? Not just the mall. Nope, not everybody goes to Chuck E. Cheese. Only parents that have 2-year-old, 3-year-olds will go to Chuck E. Cheese. Not everybody goes to church.
On the right.
Okay.
School.
School, but then you're only getting kids. Meyer's a good spot because everybody eats food.
When the presidents are getting voted.
So-
everybody's signing their, you could like stand in the middle of the line. What do you think?
Yeah, Meyer's a good place to conduct a survey. Walmart or Kroger, or maybe you try a little bit of all of them. Okay, because everybody's going to go get their food. Okay.
What about if there's a outbreak or something? You can just go.
Dang, you guys are bringing up so many.
The toilet paper
weird
aisle
things.
is
Go ahead.
Oh, thing about like doing a public area, people from like Burlington or Richmond will be going to that.
That's true. That's true. So they could be, and maybe you ask them that ahead of time before you conduct your survey. That's a good point because they're not in Kokomo technically. Maybe that would be more of a Howard County survey where they're still, or even in Burlington, they're not quite in Howard County, but they're fairly close. Yeah. All right, next one. You want to know how the residents of Kokomo feel about a ban on texting while driving. Determine whether each conclusion is valid. You surveyed 200 residents at random, 164 support it, 36 do not, 82. Okay, so they got their percentage from the math, from the fractions, right? The 164 out of 200 people. Do you like how they did their survey though?
Yes.
Yeah.
Yes, this is valid results. They asked 200 people, that's large enough. And they did it randomly. What about the first 15 residents who drive through your neighborhood?
No.
They did the math right. 5 out of 15 is 33%, but I'm not concerned about the math. I'm not concerned about the results at all if they conducted a poor survey. There's two things wrong with this. What's the first thing? Well, you have to be able to tell me what's wrong. If you don't like it, tell me what's wrong. Dane?
There's only 15 residents.
Yeah, too small. Too small. It's better than 2 residents. I get that, but it's still too small. Okay. What else, Aiden?
Yeah, there's so many people that are in your neighborhood.
Yeah. I mean, there's lots of neighborhoods in Kokomo. This is just being lazy. Okay, and that's really what a bias survey is. I'm just gonna go ask the people near me, right? Okay, this is lazy. You're only asking people in your neighborhood. You want to make sure you do a random survey like they did in the first one. And I'm gonna guess most people probably do support the ban. Okay, if I'm driving my family, with my 9-month-old in the back seat, okay, I don't want a 16-year-old kid who just got their license texting, swerving into my lane into oncoming traffic. So most people are going to agree that you should not be on your phone while you're driving. Now, you can obviously do and now Howard County actually has a no cell phone ban at all. So you can't even have the cell phone in your hand. You can't even be, technically you can't be calling anybody. Like if they see you on your phone, they can pull you over and ticket you. And you're like, well, I was just, it doesn't matter. I was just setting it, that doesn't matter. If they see it in your hand, they'll pull you over. Okay. I haven't heard of anyone yet that has gotten that, but the texting one's been around for a while. Now they did now they're doing. Yeah, so that's why all these cars are coming out now that have the Bluetooth technology where you can do hands-free.
And they have.
Is it?
Yeah.
Some people are putting that thing on there, like, it's by the shit. It's like a magnet thing. Yeah, and you put your phone in it.
Yeah, so you don't have to be touching it. And because a lot of people use that for like their Google Maps and stuff like but that's different, right? You can set it, you can get it going and then set it right there and you can take
But
off.
you can still be
Yeah.
texting.
Well, let's hope that they're not doing that, but that's what that's for, is for people who use that to charge and use Google Maps. So,
Yeah.
Because at least in your hand, you can kind of check on the road.
all right, so we talked about these words already. So an unbiased sample is actually what we're looking for. This represents the entire population and it's selected at random.
Remember when Google tried to make Google boxes?
Yeah.
That didn't work out very well. Selected at random and it's large enough. You can't have a survey that's too small. You can't conduct an experiment that way. Okay, so unbiased is good. Biased is bad. That means you don't represent the entire population. You favor one or more parts over the others, whether it's you're umpiring a game that your child's playing in or your little brother is playing in or whatever. Okay, that would be something where we would probably want to make sure, which is weird because we have actually had football games even this year where our high school principal has reffed our games. Probably because they couldn't get enough refs to come out and do it, so somebody had to.
I
So,
remember when you got really mad at that one ref at the football game.
who, me?
Yeah, I remember you went off. It was you and the other coach.
I'm Jason's dad.
Was it Jason's dad? I forget, but when we were at
I can't imagine me ever getting mad at
When we
a.
at Eastern, I forget when we were, but you went off.
And Coach Smith, and Coach Smith.
What game was that?
I don't remember.
It was when we were facing, I think it was our last game.
There was a game I remember 2 years ago where we were up by a lot, and I was trying to get guys in the game, and we stopped them on 4th down. Well, the guy went out and spotted the ball at the 5 yards ahead, for whatever reason, and so they'd already moved it. And I said, no, that's not a 1st down. So I was arguing and yelling. And I was like, Matt, do a measurement. Well, they'd already moved the chains, so they couldn't even do the measurement. So they're like, you're already up by so much. What do you care? I'm like, no, when you have a team of 30 kids, it's nice to get people playing time on offense. And it was frustrating. I didn't get too mad because we were up by a lot. But if we were down, I would have really been upset. All right, you want to estimate the number of students at Western High School who ride the bus. Okay, this is Western High School. That's my population. I'm looking for the samples. Tell me whether the sample's biased or unbiased. 4 students in the hallway. Unbiased is good. Do you guys agree this is good? Biased is bad. Why do you think it's bad? Yeah, it's biased. Yeah, it's way too small. I mean, think about it. There's what, 800 kids or so in the high school, more than that. You're gonna ask 4. Lazy. All the students who do marching band. Biased. I don't know about you, but there's been a lot of times I've gotten to school and they're out practicing because they get there at 6. So you ask some of these kids, I'm trying to estimate how many students ride the bus, and I'm gonna ask the students who don't ride the bus, right?
So you hear ding, ding, ding.
Yeah. You just ask the band, and that's biased, it's not random. 50 seniors at random.
Unbiased.
Nope, biased. It's only seniors. Thank you, Tobin. You can't only ask one grade level. You got to include the juniors, the sophomores, and the freshmen. How many 18-year-olds do you have on your school bus?
I have one, maybe 2.
I didn't say high school students. There's probably a few of those. 18-year-old seniors
Yeah.
that have had their license for a couple years.
Well, they say it's because.
Why would they? Unless
Because they
they,
say it's, if you take the bus, it's free gas. You don't have to pay for
True,
gas in your car.
true.
I've
I
had
get that.
have 2.
I get that. Okay, so you got 2 on your bus. I'm still saying it's a pretty low number though, right? Me? I'm on the way, but I wouldn't want to get to school right before school starts. I get no preparation time.
Yeah, Mr. Bright has his own.
Yeah, and then instead of a 4-minute ride home, I'm going to sit on the bus for 20 minutes as we bounce around and I don't get dropped off at my house. I'll just drive.
I mean, I'd rather ride the bus because you don't have to wear a seatbelt. That's just way more free.
I guess you could be on your phone and you won't get the texting. Yeah.
I won't get.
What about 100 students at random during lunch?
That's unbiased.
This is unbiased, and you can argue, well, what lunch are they going to? They didn't say, are they going to
But every
A
grade
lunch,
is
B
the
lunch,
same
C
grade.
lunch?
Yeah.
Okay, doesn't matter as long as they were at all of them. But everybody does, if you were gonna go to a certain class, lunch is the class to go to because everybody has it. You probably won't get asked if they're only asking 50 people. You probably won't get asked, but everyone had a chance of randomly getting selected. Okay, so this is unbiased. Okay, you want to estimate the number of 7th grade students at Western Middle School, there's our population, who consider it relaxing to listen to music. So you randomly survey 15 members of the band. Bias.
Wait, can we
Again.
do this survey right now?
No, that's not based. Biased. Again, you're only asking, you're favoring one group over another. You can't only ask just the band, which if we're being honest, they probably like listening to music or at least playing it. Your friend surveys every 5th student whose name appears in an alphabetical list of 7th graders. Because everyone's,
It's only the 7th.
oh, it's only the 7th grade. This is also biased. It says, oh, no, you're right. Yeah, thank you. 7th grade students at Western Middle School. Thanks, Brady. Go get candy for reminding me of that. Okay. Well, did you see it? Did you notice it?
Yes, I did.
It's unbiased.
I noticed something.
They did it. Hold on. They did it randomly. Where? Did I? I spelled BIA. Oh, here. Oh, whoops. Hang on a second. Yeah, I don't do spelling mistakes for candy. Sorry.
Yeah, can you get a piece of candy?
Yeah, I should get a piece of candy.
Did you not just hear me say I don't do spelling mistakes? Sorry.
The last thing you want.
Get that bottle off your head, please. Hey, you need to stop. Raise your hand if you have something to say. The results of an unbiased sample are proportional to the results of the population. You can use unbiased samples to make predictions about the population. This is what they do. This is why they survey people, to make a prediction. This is how businesses and companies do it. They put out polls. That's how they know, or they look at their data and see, okay, what's our hottest selling item? Or if they're McDonald's, what's the time of the day that's the busiest where we need to get employees there? We need more employees working this particular shift. They look at their data, right? They make inferences based on what's happened before. They're able to make predictions, or if they're wanting to try maybe a new item, you might sample it with a few people and see what they think, and then you can make that decision. So if you do it in an unbiased way, remember unbiased is good. If it's unbiased, then your results are good, and therefore you can make a good prediction. Yes, Brennan.
Riley's has long slide.
Okay, let's stick with the notes right now, okay? You asked 75 randomly chosen students how many movies they watch in a week. There are 1,200 students in this school. Predict the number of students in the school who watch one movie each week. So I'm gonna set up a, what's that look like to you? A proportion. I'm gonna set up a proportion. We did proportions earlier. All throughout this chapter, we've used our experimental probability to make predictions. Now we're using a sample to make predictions. Okay, so when you set up a proportion, how does that say that? Has that been up there the whole time?
Yeah.
Oh, well, okay. When you set up a proportion, the first ratio is going to be your sample ratio, and the second one's going to be your population ratio. Okay. How many students did I sample? 75. I didn't sample all 1,200. Okay, I asked 75. And how many of those 75 say they watch exactly one movie a week?
21.
Okay, 21 out of 75. Okay, that's an experimental probability, right? That's experimental. I actually asked people, and that's what I got. So if 21 out of 75 people watch one movie, how would I use that information to make a prediction? Tobin?
Subtract that from the total.
Vernon? Hold on, I'm still working on setting up the proportion. I'm asking you what the next ratio should be. Owen? You got it. Yeah, X out of 1,200. So again, 21 people that I surveyed, 21 out of 75 people said they watch one movie. So how many X out of 1,200? And now I can make a prediction based on the entire population. And again, this only works if it's a good survey. You have a large enough sample, it was done randomly. Okay, so I can go ahead and cross multiply this. 75X. Someone tell me what 21 times 1,200 is, please.
25,200.
Okay, 75X equals, say it again.
25,200.
Okay, and then divide by 75, Cal, and we'll get our answer. 336. It's a story problem. It needs a label. We were surveying students. You want to be specific, you can say students who watch one movie, but I'm okay with you just saying 336 students. That's how many I'd predict that watch one movie a week. Again, I can't ask all 1,200 kids, but I can ask 75. Maybe not in one day, but in a couple of days I could get to 75. And as long as I do it randomly and I don't ask the same person twice in those 2 days, then I would be fine. This would be a good survey and I'd have good results from that prediction. Yes.
I already did the form for tonight. I did it different.
How did you do it?
I did 1,200 divided by 75. Got
And then times it by 21. Okay, that's the same thing. So I did times divide. You're doing divide times. You're doing it in just a different order, okay, which is fine in this case. Did you set up a proportion for it? Okay, go back to your work paper, and I don't need you to change any of your work, but I do want you to write down what your proportion was. So when I look at your work papers, I want to see your guys' proportions. Okay. Sound good? Yeah, which I know that when you started early, you don't always know what I'm expecting. The other classes didn't even get this far. So they haven't even gotten to the proportions part. So you know what their question was? Do I even need a work paper? I'm like, yeah, you'll need one because we're going to get to this stuff. Yeah, on a lot of the problems tonight, you can just put biased or unbiased, or you can put that, or you can even, if it gives you multiple choices, you can do A, B, C, D, right? But yeah, you will need to start showing work. Write your answers down for sure, but start showing your work when you get down to here. And we will finish these notes on Monday. And you know what else we're going to do Monday? Start your chapter 10 review. This was the last section of chapter 10. That too. All right, I'll see you guys Monday. Have a great weekend. That's fine. That's even better, to be honest, because your brain is seeing that entire thing. I just know some people are lazy and I mean, yeah, as long as they're doing it, I'm not caring. But if you want to do that, that's awesome.
I just didn't know if you just wanted to.
No, that's fine. Keep doing it. Yeah, it's fine. Mm-hmm. See,
Scooby-Doo.